Hello everyone. This is a introduction to using New Zealand Grapher, and in this case I'm going to deliberately use a time series analysis of a set of data that's not terribly time series compliant, if you like. We've got a set of data here in the New Zealand Grapher library called daily attendance, and daily attendance means attendance on Monday, Tuesday, Wednesday, Thursday, Friday of the week. And it looks like the data set that we've got here is for the years 2000, 2001, 2002. So we've got 3 years, and we've got 1 week of data for each of those 3 years. It's slightly confusing here because we've got 2000 week 1, and we've got an attendance value there. But what that first value is attendance on Monday for that week taken out of the year 2000. This is Tuesday, this one is Wednesday, this is Thursday, and this is Friday. And we'd be interested in seeing if there is a recurring pattern of perhaps declining attendance on Fridays. So we've got 2001, 2002 data, and we may say in a school have introduced some new policies that we hope would encourage people to keep attending on Fridays, but in this particular setting, there may be some evidence that people are not attending classes on Fridays, and there could be all sorts of reasons for that. Perhaps they don't value the activities that are going on Friday, or sometimes maybe they just want a long weekend. In any event, before we can see if there is a pattern of declining attendance or increasing attendance, as the case might be, we need to have a look at some graphs. So let's start doing that. So our first step in New Zealand Grapher will be to go down to the section that's called Time Series and click on that, and let's have a quick initial look at the different data sets in a visual format. So I've set up 2 variables here, which are the same as the column headings over here, day and attendance, and remembering that for our data, the first value is going to be Monday, the next one's Tuesday, Wednesday, Thursday, Friday. So I'll definitely be changing some of these because otherwise it's pretty confusing data set. So we'll call this attendance in 1 week, and I'll put in here days, Monday to Friday, something like that, which tells me what the attendance, that's fair enough, it's the number of students that turned up. Okay, and I can update that graph so I can see what's going on. Days of the week, just trying to make it so that it's a little bit clearer what's being graphed, because this W1 and W5 is a little bit confusing if you're not familiar with that data set. Okay, so in the first instance, we look at a very quick look at the seasonal implications of what we're doing, and so our first look at this data shows us that there appears to be a trend line there that indicates a decline in attendance during the week, and a decline in attendance over the years. So a long-term trend, if you like, of declining attendance overall. And our seasonal analysis looks like predicts a decline in attendance, but it also is indicating that these lines are pretty far away from the dotted line. So okay, we've got other graphs for doing this, making comments about seasonal effects, and we should use those. Okay, so what we've got here is the data for each year superimposed one on the next. We can see that for 2001, attendance peaked on Wednesday, but for the other two years, attendance peaked on Thursday. So we could say that attendance peaks in the middle of the week. Can't say that attendance is great on Mondays by the look of it. Was the case in only one year, and we can see that there is quite a big variation here on Fridays. So in 1 year, the number of people that didn't attend was 2 less than did attend on Thursday, but for 2001, we can see that on Wednesday we had 26, but by Friday we got down to 22, and there'd been a steady decline the whole time. What we can draw from that is that there doesn't appear to be a very consistent seasonal pattern, though there is an indication that things definitely do decline on Fridays. And that would be about all we could say about that graph at this point. What we'd be interested in is the residuals, because the residuals are going to tell us whether or not seasonal effects, we want the recomposition file, that one. This graph is going to tell us that whether or not our predictors are going to be good. We can see the predictable, a little bit of a pattern here. So Friday, lower attendance, Friday, lower attendance, Friday, lower attendance. But there are the first 2 week years sort of a little bit similar. The third year is a little bit similar, though what we can see here is that our predictor for Fridays, this is a Friday here, the predictor for Fridays is very far away from what we would expect the Friday values to be. What we're saying is this red line here is indicating there's a lot of variability when we do predictions for Friday. Our predictor can't be relied on terribly much. If this red line was staying inside the boundary for 1 and -1, then that would be mean that our predictor line is okay, that we could rely on our trend line, if you like, to give us a good value for a useful forecasting value. But we can see there's a huge variation here, so the forecasting's not likely to be terribly useful for us. And if we go and actually have a look at the forecasting, the forecasts, and we can see there that the forecast range of values, so our estimate would be here. So if we're looking at, say, attendance for Thursdays in 2003, then we can see that the range from here down to here is very large. We're looking, just eyeballing the graph, we're looking at attendance on Thursdays. Our prediction is somewhere between 22 and 30, which isn't very helpful for a teacher. They're going to say you could have 22 in your class, or you could have 30 in your class, and for planning purposes, it's not very helpful. And we could look at the numbers rather than just the graph. Presents the same information as the graph, but sometimes the numbers are a little bit easier to follow. In this case, for 2003, our prediction is that we'd have 24 students in class, 23.9 will be rounded up, but it could be anywhere between 22 students and 26 students. So it's a 4-student range there that we'd be looking for. And on Friday, which is the other day, we'd be looking at 24 students in our class, but it could be anywhere from 19 to 29, so it's a 10-student range. So our prediction is that between 20 and 30 students are going to turn up to class, which is quite a high number. So Yes, that would be all of the analysis, if you like, artifacts that we would be wanting to collect and present in a report. So we'd get that table that I just showed you, we'd get this graph, we would just right click on it and save image as, and we'd be able to include this graph in a report just as it is, and we'd do the same for the other graphs that we've just been through too. So we'd cover this first one's not terribly useful, but this recomposition one is, and so we'd put this graph in, and we'd probably spend quite a bit of time discussing this graph in context to explain what the graph is saying and whether or not we can use it for forecasting accurately, and to tell us what's happening in terms of attendance in this particular class or institution. Okay, so that's just a very brief introduction to what the types of graphs that I'd be wanting to extract from the data using New Zealand Grapher. And yeah, in the next tutorial, I'll be focusing more on using these existing graphs and writing them up in a way that's likely to gain some marks if it's going to be an assessment. Okay, we'll see you then.